Good morning, students. In today's lecture, we will discuss another important concept used in thermal processing of milk, called the Z value. The Z value helps us understand how sensitive microorganisms are to changes in temperature during heat treatment. In this session, we will learn the definition, calculation, graphical interpretation, and practical significance of the Z value in dairy processing. Let us start with an introduction to the Z value. The Z value is considered a measure of heat sensitivity of microorganisms. It tells us how much the processing temperature must change to cause a tenfold change in the D value. In other words, Z value helps food engineers design safe time-temperature combinations during thermal processing. Now, let us define the Z value formally. The Z value is defined as the temperature change required to produce a tenfold change in the D value. Mathematically, the formula can be expressed as Z is equal to T2 minus T1 upon log D1 minus log D2. This relationship is obtained from the slope of a graph between log D values and temperature. The Z value is usually expressed in degrees Celsius or degrees Fahrenheit. Let us understand the relationship between temperature and the D value. As temperature increases, the D value decreases. This means microorganisms are destroyed faster at higher temperatures. For example, if heating temperature rises, the time required for microbial destruction becomes shorter. Therefore, temperature and D value have an inverse relationship. The Z value represents the temperature change required for one logarithmic change in the D value. If temperature increases by Z degrees, the D value decreases by a factor of 10. Similarly, if temperature decreases by Z degrees, the D value increases 10 times. This concept helps engineers predict microbial survival under different heating conditions. The Z value can also be determined graphically. To do this, we plot log D values against temperature. The resulting graph forms a straight line. 2 points on the line can be selected to calculate the Z value using the temperature difference and the change in log D values. The slope of this line represents the Z value. Another important aspect is the temperature sensitivity of microorganisms. If the Z value is small, the microorganism is highly sensitive to temperature changes. A small increase in temperature will significantly reduce the D value. On the other hand, a large Z value indicates that microorganisms are less sensitive to temperature changes. The Z value has important practical significance in heat processing. It helps engineers decide equivalent thermal processes. It also helps balance product safety and product quality. By using the Z value, we can optimize time-temperature combinations to achieve microbial destruction while minimizing quality loss. In the dairy industry, the Z value is used in several thermal processes. It helps design HT-ST pasteurization conditions. It is also applied in UHT processing and sterilization systems. By understanding microbial heat resistance, processors can ensure that milk becomes safe while maintaining nutritional quality. This slide provides a visual summary of the D value and Z value concepts. The D value represents the time required for a 90% reduction in microbial population at a specific temperature. The Z value represents the temperature change needed for a tenfold change in the D value. Together, these parameters help engineers design different heat processes that produce the same level of microbial destruction. To conclude, the Z value is an important parameter in thermal processing of milk. It measures how temperature changes affect microbial destruction rates. Understanding the relationship between D value and Z value allows food engineers to design efficient and safe heat treatments. Thank you.